Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Mayfield. And in this video, we're going to be working on that real number system, homework number 1. And we're trying to make sure that we are getting those values simplified first. That way we know for sure what those values are going to be and which subsets, so there could be more than one, which subsets those go under. So what I'm going to do for this first one is I'm going to use that wonderful Desmos calculator. Make sure you're on that Virginia testing one, so that way you get good practice with it. If you want to change it to dark background, you can use that reverse contrast option in there. But anyways, so what I'm going to do, I'm going to type it exactly how it looks. Again, if you change it however which way, it's not going to be the same. So for example, if I said it's the square root of -22, you're going to get not a good answer. However, if you type it exactly how it looks, so I'm going to say, all right, the negative square root of 22, and I get my value right here. And usually I just go to those first couple decimals, and then what I can do is I can show that, hey, that keeps going and there's no pattern. So I'm going to say this is going to be about -4.69, and then if you notice, I'm going to say that it keeps going. Again, those 3 dots after those values mean it does not end. So let's kind of remember what we need from this real number system. So again, when you have this here, again, I'm going to make this little chart for myself. That way it's easy to remember. So I have my real number system is split into 2 groups. I have my my set of values that are not ratios, meaning they cannot be displayed in the form of ratios. Again, those are the values that do not end and they do not repeat. However, on the other side, we got some rationals. Inside of those rationals are those integers. Inside of those integers are whole numbers, and inside of those whole numbers are those natural. So make sure, maybe if you need to draw some lines here for yourself, let me actually do that. So we're saying that this entire thing is that real number system. And what you can say is, again, that they have those 2 groups. You have those rationals, and each of these are going to be your rationals. So make sure you're kind of having this idea where they are contained within it. So inside of those rationals, you have your integers, whole numbers, and your natural numbers. Inside of those integers, you have your whole numbers and natural, and inside of those whole numbers, you have your natural numbers. So make sure you're saying that if that I'm including and saying maybe if it's a natural number, it would have to be all 4. So just make sure that you are very mindful of that. So let's get back to this number 1 so we don't get too sidetracked. So I'm saying that this value does not end and it does not repeat, therefore it is irrational. So we're going to say that it is irrational. That means that it can't be anything else. Again, there's no subsets underneath the irrational numbers, and so we're just going to let that go. For number 2, it is 25, and so let's think, okay, can I count to 25? You better believe it. I hope you can too. So again, we're going to say that's a natural number, and like I said before, hey, maybe if I am including all of these, meaning if it is a natural number, it also has to be a whole number. If it's a whole number, it has to be an integer, and if it's an integer, it is also going to be rational. So make sure that you are including all 4 of those for your counting numbers. So now let's get, we have a mixed number. So again, you have your whole number and the part. So you're going to say, all right, well, if I need a little bit of help with this, again, it's going to be like this. I'm going to say, all right, it's going to be 2, and so I'm going to have a plus, and I have my part. So I'm going to have 2 over 5. So my value here is going to be is equal to 2.4. So I'm now looking at this value here is the value that I'm going to try to figure out, okay, which is it going to be rational or irrational? Well, we know it stops right there, so it ends at that decimal value. That means it is going to be rational. However, is it an integer? We can say, hey, it's not an integer because it has that decimal value. So make sure you can set, have those check marks for yourself. You can say, okay, I'm going to stop at just rationals for that one. For number 4, it has 5.16 repeating, and make sure you have that line in there, what that is saying is it's going to repeat. So for example, if I type this in, it'd say 5.161616 over and over and over again. Again, you would be able to see it like that. Since it repeats, that means it is rational. However, since it has a decimal value, that means that it is not an integer. So we stop at just rational. For number 5, make sure again you are simplifying first. So when we take that square root of 25, that's a perfect square. Just in case, let's check our Desmos calculator to be sure. And very good, yes, it is equal to 5. So we're going to say, okay, that value that we're looking at now is going to be 5. So where we place 5, well, it's a counting number, so that means it's going to be rational. It's an integer. It is a whole number, and it is a natural number. So make sure you're including all 4 for this value of 5. For number 6, it says -9/3. Again, you want to make sure you are simplifying first. Again, we can kind of already see it is a ratio, meaning it is a fraction. So right away, I kind of already know, hey, it's rational, but let's make sure we get that simplified answer. So I'm going to have the negative, and then I have a fraction. Again, what I can do is I can use my arrow keys. I can go up and down between the numerator and denominator, but I'm going to say, okay, I have 3/9, or 9 divided by 3. Make sure you have that negative sign out there. So it's going to say that value that we're looking at is -3. So yes, -3 is rational. It is also an integer. We can see it on a number line. However, it is not a whole number, and be able to say, okay, it is not a whole number because, and then you would say because it is negative. So we would not include it in the whole numbers. For number 7, we have that wonderful Greek letter. If you're ever unsure, be mindful and use that Desmos calculator. You can click that pi button. Again, that has that 3.14159, so on and so forth. Again, you can usually stop at that second decimal place and you see no pattern. And so you can say, hey, it does not end, it does not repeat. Since it does not do both of those things, it is irrational, meaning it cannot be displayed as a ratio. Same kind of idea for number 8. There's no pattern. The 3 dots means it keeps going, so therefore it is also irrational. Again, be very mindful as you are putting those labels down. Again, take your time, rewind, replay, slow down, speed up, whatever works best for you. For number 9, we have that wonderful 0 value, and so we're going to say, all right, we know that it is rational, we know that it is an integer, and it is a whole number. And again, make sure you're seeing why it's not a natural number. Anytime you're counting something, you always start with 1. So we're going to say that it is just a whole number. Lastly, but never leastly, we have 2/3. Again, right away I can say, hey, that's a fraction. I know it's a ratio, but I can check to see, hey, I want to make sure I simplify. Let me double check to see what kind of values we'll get. So let's actually put that in. I have a fraction, so I'm going to say 2, and then I have over 3. So if you notice, what happens there? Well, those values keep going, and usually when it cuts off like that, it's just rounding. So we can say that, hey, it's that 0.66, and then that repeats again. So even though it does not end, it does repeat, so it is still rational. Again, we already proved that because it is a ratio, so we already know that for 2/3. However, why is it not an integer? Well, it's not a full amount. It has those decimal values in there, so that's why we cannot include it in the integers. So again, make sure you're reading those directions carefully, and as always, super slam that subscribe button.